Today we're going to be talking about data and how we can organize data and read data from circle graphs and scatter plots. So let's start off with circle graphs. Now in a circle graph, all the sections will sum up to 100%. That's the main thing you want to take away from that. So here's an example. The circle graph below shows the Miller family's monthly budget. Part A. What percent of the budget does the Miller family spend on utilities? Well, if everything has to add up to 100%, and we know exactly what percent is spent on everything else, we simply have to subtract each of those from 100 to get the utilities. So 100% minus 15, minus 35, minus 30, minus 10 comes out to be 10. So 10% of the budget is spent on utilities. All right, part B. If the Miller family has a monthly budget of $2,000, how much do they spend on groceries each month? Well, since we know that they spend 30% of their budget on groceries, and we know in total their budget is $2,000, we can write a proportion to solve this. So this would be 30 over 100, that's what 30% means. And we know that the total budget is $2,000, and we want to know how much they actually spend on groceries, so x over 2,000. Now we can cross multiply, so 100 times x equals 30 times 2,000, which is 100x equals 60,000. Divide both sides by 100, and we get that x is equal to 600. So they spend $600 on groceries each month. All right, part C. If the Miller family spends $150 on transportation each month, how much do they spend on their entire budget? Now we're taking this part separately from part B, because in part B we were told, okay, well, if their total is $2,000, then how much would they spend on groceries? But now we don't know how much they actually spend on their entire budget, but we're saying if they spend $150 on transportation, then how much would they spend on their entire budget? So it's a separate question. All right, well, what percent do they spend on transportation? That looks like 10% from the circle graph. So I'm going to write 10 over 100 equals, and if they spend 150 and we want to know how much they spent on their entire budget, this would be 150 over x on the other side. Now we can cross multiply, so 10x equals 100 times 150, which would be 10x equals 15,000. Divide both sides by 10, and you get x is equal to 1,500. So how much do they spend on their entire budget? That would be $1,500. All right, let's take a look at example 2. The circle graph below shows the budget of a school's expenditures. What are the total expenditures in dollars? Well, if this breaks it down into what each amount of the total budget is spent on each portion, then we can simply add all those portions together to get the total expenditures. So 2,900 plus 1,100 plus 1,400, 2,200 plus 2,400, add those all together and you get 10,000. So the total expenditures in dollars is 10,000. Okay, now part B. What percent of the total expenditures is spent on field trips? Well, since we know we have 2,900 that's spent on field trips, and the total we found was 10,000, and we want to find the percentage, in other words, we want to find what x is over 100, then we can set that proportion up and cross multiply. So now we have 10,000 times x equals 2,900 times 100. That's 10,000x equals 290,000. Divide both sides by 10,000 and we get x is equal to 29. Now this is 29 over 100, so that's as a percent. So our answer here is 29%. All right, part C. What percent is spent on dances and student awards? So we want to add dances and student awards, so 2,200 plus 1,400, and then we'll put that over the total, which is 10,000. We're trying to find a percent, so we want to set this equal to x over 100. And now we can simplify and cross multiply. So this would be 3,600 over 10,000. Cross multiply, so we have 10,000 times x equals 3,600 times 100. Now 3,600 times 100 is 360,000. Divide both sides by 10,000, and we get 36 for x. Now remember that 36 here is over 100, so we can write this as a percent. So this would be 36% of the budget is spent on dances and student awards. All right, part D. What percent is spent on neither store supplies nor miscellaneous? So in other words, everything else. So that would be field trips, dances, and student awards. Let's add those all up. So 2,900 plus 1,400 plus 2,200. Put that all over the total, 10,000. And we're trying to find a percent, so set this equal to x over 100. And now let's simplify and cross multiply. So now we have 10,000x equals 6,500 times 100. And now we can divide both sides by 10,000, and that leaves us with 65. 65 is over 100, so we'll write this as a percent, 65%. So 65% of the budget is spent on not school supplies and not miscellaneous, but everything else. All right, let's move on to scatter plots. Now, what is a scatter plot? A scatter plot shows the relationship between two sets of data. We can use what we call a line of best fit to represent the data in a scatter plot. Now, if the line of best fit has a positive slope, we say that the data has a positive correlation. If the line of best fit has a negative slope, we say that the data has a negative correlation. And then if it is unclear if the line of best fit has a positive or a negative slope, we say that the data has no correlation. All right, take a look at example 3. The table below shows the number of years of work experience and the yearly salary in thousands of dollars of 8 people who have the same job. So just taking a look at this, we see years of experience X. So someone with 0 experience has a yearly salary of 25. This is in thousands of dollars. Another person with 0 years of experience is getting paid 30,000. Someone with 5 years of experience, 35,000. Another with 5 years of experience, 40,000, and so on. All right, so part A. Make a scatter plot using the data from the table. Now you have this graph already here. We see that along the x-axis, we have the number of years of experience. Along the y-axis, that's the yearly salary. So let's go ahead and plot what we have here from our chart. So we have 0, 25, 0, 30. We have 5, 35, 5, 40, 10, 50, 10, 55, 20, 70, and 20, 75. Now, part B, draw a line of best fit for the data on the scatter plot you made in part A. Well, to draw a line of best fit, the easiest way to think about this is try to draw a straight line that goes directly in between all of the data points. In other words, after you've drawn the line, you should have the same number of points on either side of the line. So, for example, this is a line of best fit. You can see here that I have approximately the same number of data points on either side of that line. All right, part C. Use the line of best fit you drew in part B to predict the yearly salary in thousands of dollars for a person who has the same job and 15 years of work experience. Show or explain how you got your answer. Okay, so if you're just going off of this line that I've drawn here, we're saying, okay, for someone who has had 15 years of work experience, so look along the x-axis and find 15. and see where does that fall on the line that I just drew. Well, I'm going to put this blue dot here. That's where it lands, and that looks like it's somewhere between 60 and 65. So maybe approximately $62,000. All right, part D. Write an equation that represents the line of best fit that you drew on the scatter plot. Show or explain how you got your answer. So if you'll notice here, the way that I've drawn this line, it goes through these 2 points. So I'm going to use those 2 points to come up with the equation of the line. Now remember, to find the equation of a line using 2 points, you're going to have to start off by finding the slope of the line, and after you find the slope, then we'll plug in one of those points to find the y-intercept. So right now, I'm taking the 2 points 1050 and 2075. I'm going to find the slope. So that's y2 minus y1 over x2 minus x1. So that's 75 minus 50 over 20 minus 10. And that comes out to be 25 over 10, which is 2.5. So that's my slope. So y equals 2.5x plus b. Now to find b, I'm going to go ahead and take one of those points. I'll choose 1050 and plug those values in for x and y. Now I can solve for b. So 50 equals 25 plus b, which means b is equal to 25. And you can actually see that from the graph that I've drawn here. So my equation is y equals 2.5x plus 25.